Hello everyone, this is Cabouly speaking alongside with my great partner Alon Orlovsky, and today we are so proud to present to you our Java project. So, let's begin, shall we? You see, we used A-star as one of our search algorithms. We wanted to solve various problems using these strategy patterns, and the maze problem as part of it. We wanted to solve mazes fast and quick, and A-star does that best. A-star is like the good old Ajaxtra, but unlike it, on each stage it selects the most promising successor based not only on his distance from the graph source, but also from an estimation, a heuristic calculation to the goal. A few words about our architecture. We have a main server. This server has a remote control that communicates with it through the UDP transport protocol. This remote commands the server. It could signal him to start or stop serving clients, signal him to disconnect a specific client, and it gets status updates from what's the server doing at the moment all the time. Upon signaling the server to start, clients could connect and ask it to solve problems. When solving, the server saves the problem and its solution to the database using Hibernate ORM and sends the solution to the client. You probably noticed the word model written next to the remote control or the client. This model is an integral part of our architecture. We wanted to achieve large separation, for our code to be modular, easy to trace, and for more efficient work, for each one of us could work independently and parallel to each other. For that, we used MVP. MVP is an architectural pattern that divides code to independent layers, the view and the model. Through the observer pattern, the presenter observes and commands the view and the model. Onto the demonstration. Let's open up the main server and assign its properties, including the port in which we will communicate with the remote controller. Now, let's open the remote controller and again assign its properties. Now it's a good time to say that this dialog you see is a generic dialog. We created a class that gets a class type and creates from its fields a generic dialog. That was pretty cool. Okay, so let's send the start server signal, and what you see here in the console is loading from the database, loading of old queries, old clients' queries, names of mazes, maze and solutions. So now let's open up a client. And again, we will set its properties. Now, let's generate a maze, shall we? As you can see, the remote control is always informed of what the server is doing right now, generating a maze. And then it is sent to the client using the Huffman compressor we ourselves implemented. Now, a few cool features in our maze is that we can drag Sonic. Diagonal dragging is also allowed. Now, we can also play with the maze size as we like. We can ask the server to give us hints and also solve us the maze. So yes, this is pretty cool, and that's our winning screen. And now let's create a new client. This time it will be a CLI user interface, CLI's command line interface. And again, assigning all the properties. Okay, so you can see here the CLI in the console. And again, of course, the remote control is informed the server is generating a maze, and yes, here it is, the generated maze and its display. So, guys, now we would like to tell the server to stop work. So, let's signal him to stop. Okay, so the server got the stop signal and it terminated after saving all the data, all the new mazes he solved in the database. So guys, thank you very much for watching and we'll meet again. Bye bye.